Guys, today we are back with another problem, and today's problem is finding the vertical width of a binary tree. So this problem has got multiple approaches. This problem has got multiple approaches. I'm going to write some of the approaches over here. The first approach being using a map, okay, using a hash set, okay, and we can also use a tree map, okay. We can also use Q data structure to solve this, okay. But also we can use DFS, okay. The most easiest and the most convenient way I could do is a DFS, okay. And I will tell you while I solve this particular problem. So while solving this problem, what I can see is first I will be given a binary tree. So let me draw the binary tree, okay. So 1, 2 and 3, 2 and 3, okay. Then I have 2 is divided into 4 and 5, 6, 7, okay, and 6 is divided into 8, and 8 is divided into 9, okay. So what next? These are nothing but the children of the parents, okay. These are nothing but the children of the parents, and what I have to find out is the width of the binary tree. So width of the binary tree means vertical path. So what is a vertical path basically? So if I check a vertical path, say for example if I have this, okay, and my vertical path I want to find out. So in this case of a vertical path will be drawn like this. A vertical path will be drawn like this, okay. A vertical path will be drawn like this. A vertical path exists like this, okay, and this. Similarly this. So 1, 2, 3, 4, 5, 6. You can see we have created 6 vertical paths, okay, and we can say, oh yes, we have 6 vertical paths over here, okay. But is this how we are going to calculate and we are going to return 6? No, this is not that easy, right? So first I'm going to follow some rules while I do this, okay. So using a data structure called hash map, you know, hash map help us store the value of key and values, but hash map does not always store the values in sorted order. So what we can use is a tree map, okay, a tree map similar to hash map, and we will have a key and a value, okay. So before that, what I'm going to follow is some set of rules, okay. So if I have one, I'm moving into 2 and 3. So the rule which I'm going to start is, initially I will mark my position as 0, okay. So we are going to solve this using the concept of horizontal distances, HD, horizontal distances. So whenever we are going to calculate the distance, whenever a node is found in the left side, we are going to do -1, and whenever a node is present on the right side, we are going to do +1 by the distance. So this is -1, this is +1, okay. So now we got 1, 2 and 3. Now when 2 is divided into 4, okay, so 4 will have a horizontal distance of -1 plus -1, which is -2, and 5 is going to have an horizontal distance of -1 plus 1 as 0, okay. And similarly 3 is divided into 6, right? So 6 will have a horizontal distance of +1, -1, 0, and the right side +1 plus 1, 2, okay. And the this side, if I see 8, so for 8 it is again, for 8 what I'm going to do is my right side, right? So for in the 8 I can take a -1 because it's on my, I can take a +1, so this will become my +1, and over here for 9 it will also become my +1, okay. Whenever I'm moving over here, it's +1. So this is how I can calculate the width of for 9 I can take it as 3, okay. And 2 left side +1, 0, 0, 0. So what I can basically see is all these things 0, okay. First I will write the coordinates over here one side and the value one side. So let me write the values one side and then the coordinates. First I'm going to write the values which I have, all the possible values. I have zeros, I have -1, I have -2. What else do I have? I have +1, I have +2, and I have 3. So you can see I have 6 value. So this is the size of the hash table as 6, okay. Now I'll put the elements in the hash table. For 0, what are the elements I have? 1, 5 and 6. For 0, the elements which I have is 1, 5, 6. For minus 1, what elements do I have? For minus 1, I have the element 2. Okay. For minus 2, which elements do I have? The element 4. Okay. For plus 1, what elements do I have? 3 and 8. Okay. 3 and 8. And for plus 2, I have the element as 7. And plus 3, I have the element of 8. So the size of the tree is, you can see, the total number of elements present in the hash tree is 6, right? So the sum or value equals to 6. Okay. The sum or value is equals to 6. So this is the approach we can follow while using the concept of tree map, a queue, or a hash map, okay, or hash set. Okay. So these are the concepts which we can follow while solving this particular problem by using the concept of horizontal distance. Horizontal distance is going to give me the minimum possible distance between two possible points. So what you can see is whenever something has the point as 0, whenever something has a point as 0, 0, 0, means this all the three values in real plane lie at the same plane. So if I have a vertical plane, this is close to this, and it lies on this. So means this all lie in the same plane. Whenever I have a minus 1, you can see in minus 1 plane only one value is lying. Okay. In plus 1 plane, two values are lying. In plus 2 only one value, plus 3 only one value, and also same for this. So we have total of 6 planes. That's the reason we are giving the width of the tree as 6. Okay. We can solve this using this concept of tree map. Okay. But what if I want to do it in a simpler manner? So I can write the algorithm for a depth first search approach. Okay. Using a DFS approach. So what is going to be the algorithm? So initially we will have a class solution. Okay. A class solution, and in class solution I can have my vertical distance, which I'm going to return as int vertical distance. I'm going to pass a value which the user will give is a node root. Okay. I'm going to pass a node root. So if I have the vertical distance, now what is going to be my task? Okay. So I have the vertical distance. I'm going to do the DFS. I'm going to create a hash set, right? I'm going to create a hash set of horizontal distances. So I can write like this: hash set of type integer ABC equals to new hash set. Okay. Now I have the new hash set. What next? Now I can just call the function DFS. I can pass the value root. I can pass the starting point of the horizontal distance, which is 0, and I can pass my hash map ABC. Okay. After this, what I'm going to return? The size of my hash map, right? So I can write abc.size. Okay. So this will become my vertical distance. But what about my horizontal distance? So for that, I'm going to create void DFS function. In the void DFS function, I'm going to have a node. Okay. Pass a node as parameter. Since you can see we have the first value as the node value, then I can pass a horizontal distance. Okay. So for horizontal distance, I can write horizontal distance as HD. Okay. So int HD. Then I can pass a hash set of integer value called ABC. Okay. So in this void DFS, what I'm going to basically do, first I'm going to check if the node not equals to null, then I'm going to just give a return. This is my base case. Okay. Now I'm going to recursively call the value. So I'm going to pass a node. Okay. And I'm going to pass the horizontal distance. Okay. And my hash set. So what I can write is horizontal distance and ABC, right? So in the case of a node, horizontal distance will be HD plus 1. And in the case of what type of node? In the case of a So I have going to just check what type of node I have made. So I'm doing plus minus 1 in case of left. Okay. So what I'm going to do is I'm going to pass over here node dot left, okay, and hd minus 1 and my hash map abc for left data structure. For right node, I've already told I'm going to use hd plus 1, the initial distance plus 1 abc, okay. And over here I have to add the elements. So abc dot add node, I'm going to add the root values, right? So this is how my DFS works. Now I'm going to show you the coding implementation of this particular problem. Okay. Now I'm going to come with the coding implementation. So if you see, I've already submitted today. If you see my submission, this is using a pair of vertical map. This is the concept of using a tree map. You can see what I've done is I've taken a vertical width node root. If the root is null, I'm going to return 0. Then in a tree map, I'm going to store the values by using a queue data structure, queue in the form of linked list. And after that, I'm going to remove the top element by using pole, and then I'm going to constantly add the pairs to the horizontal distances. Similarly, I'm going to do the for left value, I'm doing hd minus 1, and for right, I'm doing hd plus 1, and then also I have to create a pairs class. But this looks kind of a clumsy process. So we are going to use a simpler process using a simple DFS method. So for that, we are passing a hash set integer abc, okay. And once the hash set is being passed, we are going to return the abc.size. So over here, we are just adding the horizontal distance. So if you just see in this code, if you see in our code, over here, what I've done a mistake is I have added the node. So what I have to do is I have to add the horizontal distance, okay. And over here also I have to check if root equals to null, then return a 0. This is also a base case which I have to do. Now let's check the code. We have done vertical width, okay. We have taken a node, we have stored in the hash set, we have returned it, the size of the hash set, and for left traversal we are doing -1, and for right traversal we are doing +1. So that was about today's problem statement. I hope you like the implementation, and we are looking forward to solve more videos. Thank you.